In today's lesson, we'll be looking at Chapter 3, Lesson 3 on prime numbers and prime factorization. Our goal is going to be twofold. We're going to take a look at factoring numbers and then also finding the prime factorization of a number. In order to accomplish the goals of today's lesson, we want to know what a factor is. A factor is simply a whole number that divides into another whole number evenly, meaning that it has a remainder of 0. Oftentimes we're going to be asked to list all the factors of a number. I find that the easiest way to do this is to use something called a factor T. What I mean by a factor T is I take whatever number that I'm looking for all the factors of, so for example the number 24, and I make a big T around it. The reason I do that is it helps me structure a look at each of the possible factors that I have. All the numbers from 1 to 24 are potential factors, but by organizing this way I can limit the amount of numbers I actually have to check. How I use this method, I start with the number 1. 1 is a factor of every number, so I can use 1 and 24, so the number itself is going to be one pair of factors. I always put pairs of factors opposite of each other, and I try to go in the correct order. This is where it's going to be really helpful for you to remember those divisibility rules that we took a look at a couple of lessons ago. So it might be helpful for you to pull those out if you don't remember all the rules, because those are really going to help you today. Next, I move up to the number 2, the next number higher than 1. I know that 2 divides evenly into 24 because 24 ends in 4, which is an even number. So it goes in 12 times, so I'm going to put the number 12 over here. Notice each pair that I have, 1 and 24, 2 and 12, if I multiply that pair, it should give me the number 24. So I always want my pairs to equal or have 24 there. Next number I come up with is the number 3. So I need to check if 3 goes evenly into 24. If I remember my divisibility rule, I know that if I add the sum of the digits, 4 and 2, which is 6, and since 6 is divisible by 3, I know 24 is. I remember from my basic facts that I need to have 8 here. 3 times 8 is what's going to give me 24. Next, I'm going to move to the number 4, and I know that 4 goes into 24 6 times, so I'm going to pick that, put that across. And this shows us the beauty of this factor T method. Notice our factors get closer and closer together. They start on the left, the very smallest, and the right, the very biggest, and they converge towards the middle. This means that the only factor I have left to check to see if it's a factor of 24 is the number 5. Because the next number I'd get to is 6, and we've already covered each of those numbers. I know that since 24 does not end in 0 or 5, that 5 is not going to be a factor, so I know that this list is complete and I have all the factors of 24 complete and accounted for. Let's practice listing all the factors with a couple more numbers. Again, we're going to use the factor T to help us organize our information. If you felt pretty good about watching the last example, I encourage you to pause the video here and give the factor T a try on your own paper before you watch me go through it. If you'd like to see another example though, you will remember that we start off by drawing our T, and we're always going to start with that number 1, and opposite is going to go the number 120 because we know that 1 times 120 will take us back to 120. Next I'm going to look at the number 2. I know that since this is even, 120 will be divisible by 2, and I know that 2 goes in there 60 times. Next, I'm going to move it to the number 3. If I find the sum of the digits, I notice that I have 1 plus 2 plus 0, which is 3. 3 is divisible by 3, so 3 definitely goes in there. Must go in 40 times. Next, I go up to the number 4. I know that 4 goes into 12 3 times, and then into the 0 times. So we got 4 and 30 bring us 120. 5, since it ends in 0, must go in. So I can divide 120 by 5. You can use scratch work on the side paper if you're unsure, but I know that it must go into 12 twice. That leaves me a remainder of 2, so it goes into 24 times, so that's going to be 24. The number 6 is going to go in evenly as well. It goes into 12 twice, and then the 0 times. And I'm going to go up to 7. 7, remember, there's no really easy rule for, so I'm just going to try that one out on the side of my paper. Make sure it doesn't go in evenly. It's only going to go into 12 once. I'm going to get 5 and 50. I know from my math facts that 7 doesn't go into 50 evenly. It does go into 50 7, or 56, 7 times 8, so I can just get rid of all of this, and I know that 7 is not a factor, so I'm going to move up to the number 8, and if I give 8 a try, I know that 8 goes into 12 one time, leaves me a remainder of 4, so 40, so 15. Looking at 9, my 9 rule is if 3 and 6. So for 9, I'm looking for if the sum of the digits are a multiple of 9. And my sum of digits was 3, so that's not a multiple, so 9's not going to go in. 10, though, it ends in 0, so I know that 10 should go in. 10's going to go into 12 one time, and then 20 twice. So now here again I see the beauty of this method. Even though this was a lot longer, I've still really condensed the number of factors I have to try. The only number I still have left is 11. I don't think it goes in, but just to be sure, I'm going to try my division, do some scrap work. 11's going to go in once. I'm going to go 10. It's not going to go in evenly because I'm going to have to put 0 up there and some decimals. So I can be confident that I have an entire list of all the factors for 120 listed using my factor T. Again, I'm going to go over one more example. Now that you've seen 2 of these, I highly suggest, pausing the video, giving it a try on your paper, and then catching back up with us to see what happens. But if you've gotten to that point, let's take a look at what we have for 165. Again, to do our factor T, we're going to start off by drawing our basic T shape. We're going to start off with 1 again, so 1 and 165. 2 this time is not going to be a factor. It doesn't end in an even number, so I don't have to give that a try. When I look at 3, I have to remember the sum of the digits. So 5 plus 6 is 11, plus 1 is 12, so I know that 3 must go in there, even if I wasn't sure before. It's going to end up going into 16 5 times with a remainder of 1, so 15, so 53. Then I'm going to look at the number 4, and I want to see if 4 is a factor of 165. That rule indicated I have to see if the last 2 digits were a multiple of 4. They're not. 4 doesn't go into 65 evenly, it goes into 64 evenly, so I know 4 is not a factor. 5 should be, though, because 5 is it ends in the number 5. So 5 is going to go to 16 3 times with a remainder of 1, and we're going to get 31, or 33, I apologize. And then we can continue on to the number 6. We know a number is divisible by 6 if it's divisible by both 2 and 3. Since it's not divisible by 2, it won't be divisible by 6. 7 I'm not sure of. Again, that's always a tricky one, so I'm going to give it a try. If I try to divide by 7, it's going to go twice to get 14, 25. 7's not going to go into 25 evenly, so I can be confident that 7 is not a factor. Moving on to our rule for 8. The rule for 8 is if the last 3 digits are divisible by 8. Well, I know 8 goes into 16 2 times, but it's not going to be able to go to that 5, so I can be content that it's not divisible by 8. So then I move up to 9. The sum of the digits here is 12, which is not a factor of 9, so 9 is not going to work. 10 is also not going to work. It doesn't end in 0. So now I'm up to 11. For 11, I'm going to notice that it's going to go into 16 one time. Going to get 55. So, I notice 11 is going to go to 55 15 times. So I have 11 and 15. And again, I see where this is going to really narrow down my possibilities. Now I really only have to check 12, 13, and 14. So if I use my work here, if I try 12, it's going to go in once also. I'm going to get 12. I'm going to get 45. 12 isn't going to go into there evenly, so I know it's not going to be divisible by 12. But I can try 13. If I check that, 13 is going to go to 16 one time. going to get 35. 13 is not going to go into 35 evenly, so I know 13 doesn't work. So that leaves me only the number 14 to check. If I try 14, again I'm going to see it goes into 16 one time. I'm going to get 25, and that's not going to work. So I can stop there. 11 and 15 are going to be my last factors for the number 165. In order to do prime factorization, I need to review the difference between prime numbers and composite numbers. Prime numbers are whole numbers with exactly two factors, including both 1 and itself. Composite numbers, on the other hand, is a whole number that is greater than 1 with 3 or more factors. So prime numbers are going to have 2 factors exactly, and composite numbers are going to have 3 or more factors. So let's take a look at some of these numbers in the middle. Let's see if we can put them into the examples, whether they're prime numbers or composite numbers. So if we start with the number 11, if I look at the factors of 11, I can't think of anything that goes in there evenly. 2 is not going to go in there evenly, 3 is not, 4, 5, 6, 7, 8, 9, 10. None of those numbers are going to go in evenly. The only numbers that go evenly into 11 are 1 in itself, which makes it a prime number. Let's take a look then at the number 245. Immediately when I look at that number, I notice it ends in 5. That tells me that 5 is a factor of 245. That indicates that since every number we know has a factor of 1 in itself, it's going to have 3 or more factors, and we're going to put it in the composite number category. If we look at the number 7, no number is going to go evenly into 7, not 2, 3, 4, 5, or 6. The only numbers are going to be 1 in itself. So we're going to put that in the prime numbers category. Taking a look at 561. When I look at that number, I can't think of anything automatically that goes in. 2 doesn't, 10 doesn't, 5 doesn't, a lot of those easy ones. But if I remember that 3 rule, and I look at the sum of those digits, 5 plus 6 is 11, plus 1 is 12. I know that 12 is divisible by 3. So that tells me that 3 is a factor. I don't even have to go ahead and solve that, but I know that 3 is a factor. That tells me that 561 should go in the composite numbers. If I look at the number 34, if I can grab it, well, 34 is an even number, so I know 2 is divisible into it exactly. So right away I can put that into the composite number parts. Now we have to look at 1 and 0. 1 and 0 are going to be our exceptions. 1, the only number that goes into 1 evenly is 1. In order to be a prime number, 1 must have 2 factors. Since the number 1 only has 1 factor, it is neither prime nor composite. It doesn't fit anywhere in our list. Same thing with the number 0. It does not have 2 factors. 0 would be the only number that goes evenly into 0. So 0 and 1 are exceptions. They are neither prime nor composite. Prime factorization means to write a composite number as a product of prime numbers. So what I have to remember is that product is a multiplication sentence, and I want to look at the prime numbers related to each composite number. So what that's going to look like, I use what I call a factor tree here. So we see a connection between the two methods we use. And what we do is we create a symbol and a group of numbers and symbols that end up looking like a tree. We started from the number 84, and I draw 2 branches off of that number 84. What I put in those branches are 2 numbers that are divisible or divide evenly into 84. I'm looking for factors of it. So I can use those divisibility rules to test things. I can choose any number that I know goes evenly in. So when I look at 84, I immediately think the number 2 goes in evenly, but I also know that the number 4 goes evenly into both those into that number. If I put 4 into 8, it's going to go in twice, and then 1 time into 4. Now if I look at the number 4, the number 4 is not a prime number. The number 2 goes evenly into the number 4. So I can also draw branches off of the 4 to represent 2 times 2. Whatever number I put off the pair of branches, when I multiply those 2 numbers together, they should equal the number that they come from. So since the branches off of 84 were 4 and 21, I need to make sure that 4 times 21 goes back and equals 84. Same thing happened here. When I branched off the number 4, the only way I can put something off of it is if I'm able to multiply 2 times 2 to equal 4. When I look at the number 2, though, the only thing I could put or branch off of it would be the numbers 1 and 2. The number itself and the number 1 are the only factors that go off. Well, I could do that forever. I could keep drawing branches like that. So if that's the only thing I can do off of a branch, I'm not going to continue the branch on. I'm actually going to put a circle around and stop that branch. Draw an apple on the tree to circle each of those prime numbers. If I go up to 21, however, I know 21 is not a prime number. Using that 3 rule, I know that 3 is evenly going to go into 21. Its matching compartment will be the number 7. 3 itself, though, nothing goes into it except for 1 and 3. So I'm going to circle that, put an apple on the tree. And then I'm going to take a look at the number 7. 7 is also a prime number. So since it's prime, I'm going to circle it, put an apple on the tree. Now, I know that the number 84 can be represented as 2. I have 2 2's, so I know that that would be a 2 to the exponent 2 times 3 times 7 is going to equal 84. That's the goal of prime factorization, to rewrite our number as a product of prime numbers. So this group of prime numbers, if I multiply them together, will take me back to my original. If I do 2 squared, I'm going to have 4 times 3 times 7. If I do 4 times 3, I get 12 times 7, and 12 times 7 is going to be 84. So I can always go back and do that check to make sure that my prime factorization is right. If I multiply all the numbers I get, it should go back to the original number that I started with. Let's practice with another couple examples. If you get the idea of how the factor tree works, you can go ahead, pause the video, try it on your own. If not, follow along as I go through the example with 120. Again, I could pick any pair of factors for 120 that I can think of. But when I see numbers that end in 0, I always like to choose the 10 factor. So I know that 10 goes into 120, and I have to multiply 10 times 12 in order to get 120. So those are my 2 factors. Again, I check and make sure if I multiply 10 times 12, it should take me back to 120. Since it does, I know that I've chosen a good pair of factors. If I look at the number 10, I see that it ends in an even number, so that's not a prime number. I can put a set of branches off of there. I know that if I divide 2 into 10, it's going to go in 5 times evenly. So 2 and 5, so 2 times 5 is 10. So those are going to be branches off of 10. The number 2, though, is prime, so I'm going to circle it. The number 5 is also prime, I'm going to circle that. And I'm going to go up to 12. 12 is an even number. I know automatically that 2 is going to go into it. And 2 times 6 is what's going to give me 12. 2 is a prime number, so I can circle it. Number 6 is not prime, however. I know it's even, so that means that 2 is going to divide evenly into 6. So 2 times 3 is what's going to bring me up to 6. 2 is prime, so I can circle that. 3 is prime, so I can circle that. Now the key is go back up to my original problem, and I'm going to write down 2. This time I have 3 2's. 1, 2, 3, so I have 2 cubed. I have a times 3 and times 5. Those multiplication symbols are really important because the goal is if I multiply 2 times 2 times 2 times 3 times 5, it should take me back and equal 120. So if I check that quick, I have 3 times 5 is 15. 2 cubed is going to end up giving me 8 because I'm going to have 2 times 2 is 4 times my other 2 is 8. So 8 times 15, and I'm going to get 80 if I multiply 8 times 10, and 40 if I do 8 times 5. And that's going to be 120, so I can feel confident that I did my prime factorization correctly. Again, if you watch through that video, now you've seen 2 examples. I really suggest taking a look and trying 165 on your own, but we're going to go through it together here for after you watch or complete it on your own, or if you want to watch one more before you try some on your own. So for 165, those numbers aren't jumping out to me, but I know it ends in 5, so 5 is going to be a factor. 5 is going to go into 165 33 times. So 5 times 33 gives me 165. 5 is prime, so I can go ahead and circle that. 33, though, is not prime. The number 3 is going to go into 33. It's going to go in 11 times. 3 is prime, so I can circle that. 11 is prime, so I can circle that. So this time I don't have any exponents. Each number was just used once, but 3 times 5 times 11 It's going to give me 165. Again, if I want to check just to make sure, 5 times 11 is 55. If I multiply that times 3, I'm going to get 165. So that looks good. My prime factorization is going to be 3 times 5 times 11. At this point, take a look at the rest of the problems on your sheet and give both the listing the prime factorization with the factor tree and listing all the factors of a number, the factor t a try.